Hello, welcome to another video log of the build. As you can see, we're into the framing now. Run through some details and experiences. It means I don't have that thermal bridge of a steel strap, you know, going under my frame. Constantly be thinking about where your airtightness layer's got to go. We'll start down the bottom here. Framed up the floor. You can probably see in there. We've got all I-joist construction stumps for our weight bearing points. So this is our retaining wall, and then this is where the house attaches to the retaining wall, and we got our weatherproof membrane and our termite barrier, and we've created a 20mm gap for ventilation. So from under here, I'll just poke my camera in there, see if you guys can see. There's that's for stopping the wasps and whatnot nesting up and bushfire embers. A layer of, you can probably see it in there too, mesh, steel mesh, and then that should the air should come from underneath and then go up our wall cavity all the way to the eave line and then vent out. So it's a fully ventilated cavity, but also ventilated down through the basement, because we have insulation in our floor, and I didn't want, you know, moisture going down through the insulation, then through the LVL and condensing on this wall and creating a wet spot, a danger spot. So having that cavity where the house connects to this retaining wall is helpful for that condensation in that spot there. I think that's it. We had to do all of this because of the flood zone. So this is the highest point of the flood waters, as the engineer says. That's the bottom of here, and then we've got 300mm freeboard, and then I've done my floor up from there. So yeah, it's apparently the neighbour Chris says it's never flooded up onto this plane before in the 50 years she's lived here, but the engineers have calculated a couple of dams that are upstream breaking. So yeah, if that ever happens, yeah, we'll see. So then coming up here to our wall framing, we got, obviously we had to got our airtightness layer between all our internal wall frames and our external wall frames. 140 stud construction, so that'll fit a nice R4 bat in there. Here in our wet areas, we've connected our internal airtightness layer, which is our structure flooring, 22mm structure flooring, down over the edge, so when the wall frame sits there, that's connected, and then later on we can connect the the fibre cement floor to that, and that's a continuous airtightness layer. We did forget it over there, a couple of little forgets along the way. We forgot to put this layer in as well, the first few frames. Obviously I'm doing all of this myself with a couple of helping hands, and yeah, we were so busy thinking we had our carpenter's hats on and didn't have our Passivhaus hats on at the same time. So we forgot that at the start, but we just cut down with a repo saw the wall junction, and then with a crowbar lifted the bottom plate up, and then we were able to slip the mento down and under, bunch of Orcon, sealed it to the flooring and taped it up. So it was quite easy to remediate, but yeah, it's just constant. You got to constantly be thinking about all the trades at the same time, and then airtightness as well. So yeah, when you're doing everything yourself, it gets fairly full on, and it being my first Passivhaus, or Passivhaus, because I'm not in the process of, I have started the process of certification, got a quote and everything, but I wasn't able to pay for it just yet because I'm running out of money just building it, being off work and everything. So it's the least of my priorities. My priority is to get in, and then obviously I'm documenting it all, and we'll see about certification a bit later on, unfortunately. But yeah, we'll just go through some more details. So this is the brickwork wall we were talking about. We ended up waterproofing the brickwork 3 courses deep. Waterproofed it so that hopefully if there was an air leak through the mortar, you know, by the time 3 courses down, it wouldn't travel through too much. So then we'll Orcon that gap and connect to it. This flooring as well, it's had a bit of rain, the edges have lifted a little bit, but we'll probably end up planing every gap out with the electric planer and then taping those joins anyway, so that way it will all sit flush even with the tape on there. And then we go down and either we glue with Orcon or we glue with the only glue that I found that is low VOC is actually the Selleys Liquid Nails Fast Grab. It's sort of certified Green Building Council low VOC, so between the Orcon and that I'll glue everything down. A few nails here and there, probably just little pins. We might, depending on how the blower door test goes, the initial one, we might just waterproof this whole area or Aerosana or something, just to stop any air leaks through nail holes or whatever. But we'll see how the floor responds to the air tightness blower door test when we do it. I've got my own blower door gear, so I'll be doing plenty of tests throughout the build to make sure we're super airtight. And in here, when I spoke about that insulation on that brickwork underneath, so this brickwork is all, wonder if that camera's adjusting to the light in here. It obviously goes down through the floor and into the subfloor. So we've actually thermally broken, I think I showed it to you in the last video, with the Schöck, which is like an aerated glass sort of internal core, and then wrapped in styrofoam to keep that, it's sort of thermally broken brickwork, so that our internal brickwork has, you know, is thermally broken to the outside. But the engineer required us to have this concrete column here because we've got a fairly heavy weight bearing point, and that is not thermally broken. So we've gone and we've put insulation everywhere down underneath for 600 mil past where this stands, so sort of 600 mil here, and then the same on the, well, it would be more on the outside, probably 900 mil, then same going that way and all around. So it shouldn't be open to ambient air anywhere down there, and that subfloor is 600 deep, so by the time this column gets to the footing, it's also 600, so we've reduced that thermal bridge a little bit, but that's probably the only thermal bridge in the entire house, and we'll see how that ends up functioning when all the internal temperatures balance out. We'll have a look at it with the camera and see what's happening, how much heat is escaping through that point there. Let the camera adjust again. Where possible, I don't know if it's necessary or whatever, we've tried to put the brace board on the inside. It's vapor permeable, it's OSB 3, but it's just safer putting it on the inside for condensation. It's on the warm side then. Obviously where we couldn't do it, we put it on the outside, but where we could, we did chuck it on the inside. Don't know if it makes a difference or not, but yeah, it just makes me feel happy about what I'm doing. Then with all these I-joists, they haven't been too bad to work with. Trusses are a little bit harder to insulate, so I went I-joists, but we did change the centers of the I-joists. We brought them in a little bit so that a standard bat would squeeze between the eye section of it nicer. So we brought that down. The center of the eye is about 13 mil thick. So we brought that down where it's 450 centers down to 440, and where it's 600 centers down to 590, and that way a bat, hopefully, we'll see how it ends up going, hopefully will fit in snug between the eye webbing, and the bottom cords will hold the bat up. So they haven't been too bad, and yeah, I was surprised how much you can actually cut out of them. You can see you can get a fair bit of cuts out for the heat recovery ventilation. Most of those holes are 4, so, and then where I was able to, well, in any double joists or where there's a joist sitting right hard up alongside a wall, I insulated with the poly insulation just some recycled stuff I got off a commercial job. Yeah, it's mold proof, water repellent. You know, it's great while I'm constructing and there's a bit of rain or whatever. If it does get moisture in it, it's not going to encourage mold growth or anything like that, and it's not going to rot away or deteriorate because it's quite water repellent. Yeah, so obviously everything like where the heat recovery ventilation goes up, you know, it needs to be thought about in the framing stages. Obviously everywhere where there's a double joist, I've already bored the holes through because it'd be hard to get your drill in and bore out those double joists. Yeah, so it's been going all right, apart from the couple of things we've missed, but then didn't miss. As long as you fix it, it hasn't been missed, has it? It's all right. But you know, constantly thinking about it. So where beams sit in to walls, we get the air tightness layer in there already. We create like a boot, see up here, and boot off, like wrap out the beam up there, and then we can attach our inside air tightness layer to the boot. Here where we go from first story to second story, what we've actually done is pulled the Mento up out and under the flooring, then wrapped it around the flooring, and then we'll go up on the inside of the upstairs stud and then connect to the intello that goes there. And that way we were going to just tape it to the flooring. That's our air tightness layer technically, but you have little gaps where the tongue and grooves are and stuff like that. So going as one continuous line, like they teach you in Passivhaus, you just draw one continuous line. You got to see that air tightness layer. So it's a bit of extra Mento wrapping it all the way through, but it just keeps it as one continuous air tightness layer, and hopefully that works nicely. But yeah, you just got to be on the game, on the ball, constantly be thinking about where your air tightness layer's got to go, and prep it, get it ready. Otherwise you miss bits, and then you got to retrofit. We missed. I had my carpenter's hat on at the start, and obviously you can see all the angles. You know, I'm calculating every stud on the calculator, so my boys can cut them. So I'm thinking about angles and shapes and all of that, and you sort of forget the air tightness there. But I missed in these wet areas. We should have. Well, I showed you the other one, but we should have come and taped down from the air tightness from the flooring down through here. So we'll just have to see. Sorry, I don't know if you saw that down in this area. We'll just have to tape up and use our bottom plate as the air tightness layer taped to the bottom plate. I know it's not ideal, and then we'll just blow a door test, and if we have to get under the house and all con everything up, we'll do that. We'll just have to see how it goes, but yeah, that's one little thing we're gonna have to be wary of, and see how that performs when we do the blower door test. Yeah, it's all just a bit mind-boggling doing it for the first time, but lucky it's my own house, and you know, this way I can be prepared when I bring it to future clients or whatever. I'll have done it all once before, and we can see how we go with this one. I think we'll be alright, especially with, you know, blower door testing constantly. We'll be able to find any weaknesses and, you know, jump on them right from the get-go. But yeah, that's how it's all coming about, and it's looking pretty good. I'm pretty happy with how it's coming along. Obviously breaking my leg wasn't ideal, but in the meantime we've kept going, and I'm walking around on it now and able to do some more work. But yeah, we're gonna have some nice views into the garden, trying to do as much with the recycled. You know, all these bricks are recycled. You know, I've built all of that shed out of recycled stuff. Most of that timber was from the formwork that I used to form up that back section there that you saw, that retaining wall. So I used that on the garden shed, all the tin, all the iron and stuff. Also, you know, you can pick this stuff up off Facebook pretty easy, the marketplace, usually for free. But We're gonna have a few nice exposed beams, actually, I forgot to mention, coming through. Obviously wrap them up, ready to connect your air tightness layers to them, where they punch into the wall assembly. We're gonna have another one up here, exposed beam coming flying through right there, and it will connect in up there, and then a bunch of highlight windows, but you'll see them all later in another vid. But yeah, that's where we're at. Here I did a wet area flooring. Maybe I should have wet area floored the whole lot, but I've got the wet area flooring because I'm pouring in place a couple of big concrete benches, so that'll look pretty snazzy. I've done a couple of them before. We'll see how we go with these ones, but this will just take a bit of that extra weight of where these, it'll be a ton per bench roughly, so there'll be a bit of weight here, but good internal thermal mass as well. Yes. Anyways, kids, gotta have them on the weekends. My wife often works, and I try to get things done. Another thing I wanted to point out just before I leave you is I haven't strapped any of the bottoms or tops of my frames. I've actually used these strong tie screws on there. So they've got pretty good tie down force, and you go through a lot of them, and they're quite expensive. They're about $1.50 each, but it means I don't have that thermal bridge of a steel strap, you know, going under my frame, from the outside under my frame to the inside, because I can just screw the bottom plate to the stud, and then the bottom plate down to the floor, and the top plate to my stud as well. So I just reduce all that, I eliminate all those thermal bridges as well, so they're a pretty handy thing as well. They drive in super easy. They make the job a lot faster, because nailing on a whole bunch of strap, it can take a bunch of time, but these screws, they punch in and they hold real well. So yeah, I've been pretty happy using all of those. But yeah, that's about it. I'll see you next time with hopefully a bunch more info and show you what we've been up to from now.